When you look up at the night sky, what do you see? Tiny dots of light scattered across the darkness, twinkling in silence. But those dots aren't just lights, they are suns, burning billions of miles away. Some of them are thousands of times larger than our own sun, and yet their light has traveled millions of years just to reach your eyes tonight. Everything you see, the stars, the planets, the galaxies, even you and me, all share one common origin. About 13.8 billion years ago, there was no light, no space, no time. Everything that would ever exist was packed into something smaller than a grain of dust, infinitely hot and dense. Then, in a single instant, something extraordinary happened. Space itself expanded, time began to flow, and the universe was born. That moment is what scientists call the Big Bang. Imagine, just 1 second after that explosion, the universe was filled with energy, blinding, chaotic, and hotter than any star that exists today. Tiny particles collided and merged in a storm of creation. As the universe expanded, it cooled, allowing protons, neutrons, and electrons to form. For the first time, matter existed. After 380,000 years, light finally broke free and began to travel across space. We can still see that ancient light today. It's called the cosmic microwave background, the faint afterglow of creation itself. Over millions of years, invisible clouds of hydrogen and helium began to gather, pulled together by gravity, the invisible force that would shape everything to come. In the dark emptiness, pressure built, temperatures soared, and the first stars were born. They blazed like cosmic torches, flooding the universe with light for the very first time. Inside these stars, something even more magical happened. In their fiery hearts, atoms fused together, creating new elements: carbon, oxygen, iron, and more. These are the building blocks of life itself. When the first stars reached the end of their lives, they exploded in massive supernovas, scattering those elements across space. From those ashes, new stars were born, and around some of them, small rocky worlds began to form. As the universe aged, these stars gathered into vast structures, galaxies, immense islands of light drifting through the cosmic ocean. Our home, the Milky Way, was one of them, a graceful spiral of hundreds of billions of stars, stretching over 100,000 light-years across. Somewhere in one of its spiral arms, about 4.6 billion years ago, a small star began to shine, our Sun. Around it, dust and rock swirled together, forming the planets of our solar system. One of them, bathed in sunlight and water, would one day be called Earth. The story of the universe is not just about stars and galaxies, it is about us. Every atom in your body was once forged in the heart of a dying star. You are literally made of stardust. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all were born in cosmic fire billions of years ago. The universe began from almost nothing, yet created everything. It teaches us that even from emptiness, beauty can be born. We are not separate from the cosmos, we are the cosmos, made conscious. And this great cosmic story, our story, has only just begun. Stars are the engines of the universe. They are not just points of light in the night sky, they are factories where matter transforms, where the raw materials of creation are forged in unimaginable heat and pressure. Without stars, there would be no light, no warmth, no planets, and no life. A star begins its life as a vast cloud of gas and dust, drifting silently through space. Gravity, slow but relentless, pulls the particles together. Over millions of years, the cloud collapses, growing denser, hotter, and brighter. Deep in its center, when temperatures reach millions of degrees, hydrogen atoms begin to fuse into helium. This moment marks the birth of a star, a newborn sun igniting its light for the first time. The balance between gravity and fusion defines a star's existence. Gravity tries to crush it inward, while nuclear fusion pushes outward. For billions of years, these forces remain in perfect harmony. The light and warmth you feel from our sun is the result of this delicate balance, as hydrogen atoms fuse every second, releasing immense energy that travels across space before reaching Earth's surface. But not all stars are like our sun. Some are much larger, giant blue stars that burn with fierce intensity, living short, brilliant lives that end in violent explosions. Others are smaller, cooler, and dimmer, glowing softly for trillions of years. The color of a star tells its story: blue for the hottest, yellow for medium heat like the sun, and red for the coolest. Over time, stars live out their lifespans according to their mass. Small stars fade slowly into white dwarfs, dense, dying embers of what once was. Larger stars, however, go out in spectacular fashion. When the fuel in their cores runs out, gravity wins. The star collapses, triggering an explosion so powerful it outshines entire galaxies for a brief moment. This is a supernova, one of the most dramatic events in the cosmos. In a supernova's fury, new elements are created: gold, silver, uranium, everything heavier than iron. Every precious metal on Earth was born in one of these cosmic deaths. When the explosion settles, it may leave behind either a dense neutron star, no larger than a city but with more mass than the Sun, or something even stranger, a black hole, a region of space where gravity is so intense that not even light can escape. Galaxies themselves are shaped by these life and death cycles of stars. Each galaxy is a vast collection of billions of stars, gas clouds, and mysterious dark matter, all bound together by gravity. They come in many shapes, spirals like our Milky Way, ellipses like great glowing eggs, and irregular forms that look like cosmic storms. Within them, stars are born, live, and die in an endless rhythm that has continued for billions of years. At the heart of most galaxies lies a monster, a supermassive black hole, millions or even billions of times the mass of our Sun. These giants silently influence everything around them. When gas and stars spiral too close, they are torn apart, releasing radiation so powerful that it can be seen from across the universe. Astronomers call these blazing coarse quasars, the beacons of the early cosmos. Our own Milky Way is a beautiful spiral galaxy, turning slowly like a cosmic pinwheel. It contains more than 200 billion stars and countless planets, all orbiting its center, where a black hole named Sagittarius A* resides. Every 230 million years, our solar system completes one orbit around this galactic core, meaning since the dinosaurs walked the Earth, we've traveled only a fraction of our journey through the Milky Way. Yet galaxies do not exist alone. They gather in clusters and superclusters, connected by filaments of dark matter stretching across the universe like an invisible web. Between these threads are vast voids, immense regions of almost nothingness, spanning hundreds of millions of light years. If you could see the universe from far above, it would look like a glowing cosmic web, bright threads of galaxies woven through infinite darkness. Despite the grandeur, galaxies are fragile dances in a slow cosmic ballet. Over billions of years, they collide, merge, and reshape each other. When galaxies crash, stars rarely collide directly, there's simply too much space between them. Instead, their gravitational fields interact, forming tidal waves of stars, birthing new clusters, and eventually blending into one larger galaxy. Our Milky Way is on such a path right now. In about 4 billion years, it will collide with its nearest neighbor, the Andromeda Galaxy. The two will spiral toward each other, their stars mixing like paint in water. From Earth, future skies will shimmer with new constellations, and in the end, they'll merge into a single, giant elliptical galaxy, a new home for countless stars and perhaps countless worlds. Stars and galaxies remind us that creation and destruction are two sides of the same cosmic cycle. Every explosion births new possibilities. Every end is a beginning. When we look at the night sky, we are looking into the past, light that began its journey long before humans existed. Each star is a message from across time, a silent reminder that we are part of a vast, living universe, still unfolding, still becoming. The more we look outward, the more we realize, everything out there, in some way, is connected to everything within us. The galaxies, the stars, the atoms, all follow the same rules, all came from the same origin. The story of the stars is the story of us, a story written in light, carried through the ages, waiting for us to understand it. When a star is born, it rarely comes alone. Around it, clouds of gas and dust swirl in a glowing disk, the leftovers of creation. Inside this cosmic cradle, particles collide, stick together, and slowly form larger clumps. Over millions of years, these clumps grow into rocks, then mountains, then worlds. This is how planets are born, not in an instant, but through endless collisions, gravity, and time. In the early days of any solar system, chaos reigns. Asteroids crash, comets strike, and young planets fight for space. Some are swallowed by their star, others are flung into the darkness, lost forever between galaxies. But a few find balance, orbiting in harmony, at just the right distance to survive. In our solar system, one of these worlds was Earth. About 4.6 billion years ago, Earth was a molten sphere of fire and metal. Volcanoes raged, the surface boiled, and the sky was filled with toxic gas. But over time, heavy elements sank to form the core, while lighter materials floated upward, creating land, oceans, and air. Comets and asteroids delivered water, bringing the ingredients of life. Slowly, the chaos gave way to calm, and the stage was set for something extraordinary to happen. No one knows exactly how life began. Perhaps it started deep beneath the ocean, near volcanic vents where heat and minerals mixed. Or maybe it began in shallow pools under flashes of lightning, where molecules danced and joined together. Somewhere, somehow, the first spark of life appeared, a single cell capable of growing, dividing, and adapting. It was small, fragile, and yet, it changed the universe forever. For billions of years, life on Earth remained simple, tiny microbes living in oceans, feeding on sunlight and chemicals. But these microscopic pioneers transformed the planet. They produced oxygen, turning the once poisonous atmosphere into the air we breathe today. Then, around 600 million years ago, life began to grow more complex. Cells joined forces, forming plants, animals, and eventually, entire ecosystems. From the oceans came creatures that crawled onto land. Forests grew, mountains shifted, and great reptiles, the dinosaurs, ruled for over 150 million years. But even their reign ended. 65 million years ago, a massive asteroid struck the Earth, wiping out most life in a moment of cosmic violence. Yet from that destruction, new possibilities arose. Small mammals survived, adapted, and evolved. From them, intelligence began to awaken. Eventually, one species learned to stand, to think, and to wonder. Humans opened their eyes to the stars and asked the oldest question of all: where do we come from? Every civilization since has looked upward, searching for meaning in the same night sky that watched over the birth of everything. Planets like Earth are rare, fragile worlds balanced between fire and ice, chaos and order. But they may not be unique. Astronomers have discovered thousands of exoplanets orbiting distant stars, and many lie within what we call the habitable zone, not too hot, not too cold, where liquid water could exist. Some of these worlds might have oceans, clouds, and even life of their own. Imagine standing on one of those distant planets, looking up at a different sky filled with unfamiliar constellations. Somewhere across that vast gulf of space, another being might be doing the same, gazing at our sun, wondering if someone is looking back. Life, it seems, is the universe's way of knowing itself. Out of dust, atoms learn to think, to dream, and to love. We are not separate from the cosmos, we are its expression, its voice, its consciousness. Every heartbeat, every breath, every thought is part of an ancient cosmic rhythm that began billions of years ago. The story of life is a story of resilience. From chaos came order, from simplicity came complexity, from darkness came awareness. And though we may be small, the atoms that make us were born in stars, and the light that warms us has traveled across space for millions of years to touch our skin. Perhaps the most beautiful truth is this: the universe did not just create us, it created the conditions for us to wonder about it. We are both the observers and the observed, a brief flicker of awareness in an infinite sea of stars. And sir, as we look to the heavens, we are really looking home, not outward, but inward, to the very source from which we came. The story of planets and life reminds us that every ending is a beginning, every explosion is a creation, and every moment, even this one, is part of something eternal. For centuries, humans have gazed at the stars and asked the same question: are we alone? The universe is vast, billions of galaxies, each containing billions of stars, and countless planets orbiting those stars. Statistically, it seems improbable that Earth is the only world where life has emerged. And yet, we have found no definitive proof. Astronomers began their search by looking for planets beyond our solar system, exoplanets. The first confirmed discovery came in the 1990s, and since then, thousands more have been found. Some are gas giants like Jupiter, others are rocky like Earth, and a few lie in the so-called habitable zone, where temperatures could allow liquid water to exist. These planets, bathed in alien sunlight, may host oceans, clouds, and perhaps life forms we cannot yet imagine. Scientists have developed tools to study these distant worlds. Telescopes like Kepler and TESS scan the sky for the faint dimming of a star's light as a planet passes in front. Spectrographs analyze the atmosphere of far-off planets, searching for gases that might indicate life: oxygen, methane, water vapor. Each detection brings us closer to answering the question we have wondered about for millennia. Meanwhile, humanity has sent its own messages into space. Radio waves, spacecraft, and even golden records have traveled outward, carrying the story of Earth, in the hope that someone, somewhere, might one day hear it. Projects like SETI listen for signals, patterns in the cosmic noise that might reveal intelligent life. The silence we've encountered so far only deepens the mystery, leading to new questions and new theories. One such theory is the Fermi paradox: if intelligent life is common, why haven't we seen evidence of it? Perhaps civilizations are rare, perhaps they destroy themselves, or perhaps they deliberately hide. Some scientists propose that advanced civilizations might exist in forms we cannot detect, in dimensions or frequencies beyond human perception. The universe may be full of life, yet invisible to our limited senses. We also consider the possibility of life closer to home. Moons like Europa and Enceladus, orbiting Jupiter and Saturn, hide oceans beneath icy crusts. In those dark, cold waters, geothermal heat could sustain microbial life. Even Mars, once warm and wet, may still harbor microorganisms beneath its surface. Our solar system, once thought barren, may be teeming with tiny, hidden forms of life waiting to be discovered. Exploration is no longer a dream, it is a reality. Robotic missions have mapped distant planets, landed on comets, and sent back images of alien worlds in astonishing detail. Telescopes like the James Webb Space Telescope peer into the earliest epochs of the universe, revealing galaxies, stars, and planets as they formed billions of years ago. Every discovery reshapes our understanding and expands our imagination. The search for life is also a search for ourselves. By looking outward, we reflect inward. We consider what makes life resilient, what allows intelligence to arise, and what responsibilities we hold as stewards of our own fragile planet. The possibility of other civilizations forces us to confront the fragility and uniqueness of human life, inspiring both humility and wonder. Perhaps the greatest truth is this: the universe is vast enough that life almost certainly exists somewhere else, but rare enough that life on Earth is a miracle. The search for other worlds is the search for companionship, understanding, and meaning in an infinite cosmos. Every new planet discovered, every faint signal detected, tells us that the universe is not silent, it is alive with possibility. And so, as we continue to explore, we remain hopeful. We launch probes, build bigger telescopes, and send our questions into the void. Someday, perhaps, we will find another world with oceans, winds, and perhaps creatures looking back at the stars. Until then, we keep searching, keep learning, and keep marveling at the infinite possibilities that surround us. The quest for other worlds reminds us that even in our solitude, we are connected to something immense and eternal. Life on Earth, fragile and fleeting, is part of a greater cosmic tapestry, one that extends far beyond what we can see, imagine, or understand. Every planet, every star, every galaxy is a note in a grand symphony of existence, and we, tiny as we are, have the privilege of listening, exploring, and participating in its melody. Despite all we have discovered, the universe still holds secrets deeper than we can imagine. About 95% of the cosmos is invisible to us. Scientists call this dark matter and dark energy. Dark matter exerts gravity, holding galaxies together, yet we cannot see it. Dark energy drives the expansion of the universe, pushing galaxies apart faster and faster. We know it exists because of its effects, but its true nature remains one of the greatest mysteries in science. Black holes are another profound enigma. These regions of space are formed when massive stars collapse under their own gravity, creating a point of infinite density. Not even light can escape their pull. At the center of most galaxies, including our Milky Way, lies a supermassive black hole. Its gravity-shaped stars bends light and warps time itself. Around a black hole, time slows, and space bends in ways that challenge our imagination. Einstein's theory of relativity tells us that gravity is not just a force, it is the curvature of space and time. Near a black hole, this curvature becomes extreme. If you could approach the event horizon, the point of no return, you would experience time differently from anyone far away. Seconds near a black hole could stretch into years elsewhere. This mind-bending concept shows us that the universe does not obey our everyday intuition. It is far stranger, more flexible, and more mysterious than we can easily comprehend. Even more perplexing is the possibility of wormholes and parallel universes. Wormholes, predicted by relativity, are hypothetical tunnels through space-time, shortcuts that could connect distant points in the universe. If they exist, they could allow instant travel across light years, or even to other universes. The multiverse theory suggests that our universe might be one of countless others, each with different laws of physics. These ideas stretch the limits of science and imagination alike. The universe is also full of paradoxes. The Fermi paradox asks why, if intelligent life is statistically probable, we have not yet observed it. Perhaps civilizations self-destruct, or perhaps advanced life exists in forms beyond our perception. Perhaps they deliberately avoid contact, watching silently from afar. These questions remind us how little we truly know, even as we probe the farthest reaches of space. Cosmic phenomena challenge us daily. Gamma-ray bursts, explosions billions of times more powerful than our sun, can erupt without warning, releasing more energy in seconds than the sun will emit in its entire lifetime. Neutron stars, dense remnants of collapsed giants, spin hundreds of times per second, generating magnetic fields trillions of times stronger than Earth's. Quasars shine across billions of light years, outshining entire galaxies. The universe is a theater of extremes, testing the limits of our understanding. Yet, the mysteries of the universe are not just scientific puzzles, they are invitations. They invite curiosity, wonder, and humility. They remind us that every answer leads to a deeper question. Every discovery opens doors to new possibilities. The more we learn, the more we realize how much remains unknown. And in that unknown, there is beauty, majesty, and infinite potential. Black holes, dark matter, dark energy, wormholes, these are not just abstract concepts. They are the boundaries of human knowledge, the frontiers where science meets imagination. They teach us that the universe is larger, stranger, and more profound than we can fully grasp. They compel us to explore, to think bigger, and to question everything we assume. The mysteries of the universe remind us that our journey is only beginning. We are explorers, observers, dreamers, standing on a tiny planet in a vast cosmic ocean, striving to understand the forces that shape reality itself. Every particle, every wave, every beam of light tells a story that is still unfolding. And perhaps that is the greatest mystery of all: the universe is not finished. It is still growing, still changing, still revealing itself in ways we cannot yet predict. And somewhere in the midst of this infinite mystery, we exist, conscious, curious, alive, capable of asking the questions that may one day reveal the ultimate truths of existence. The universe has a story, and like all stories, it has a past, a present, and a future. While we have traced its history back to the Big Bang, we now turn our eyes forward, to the destiny of everything we know. Cosmologists have imagined several possible futures, each as fascinating as it is mysterious. One scenario is the Big Freeze. As the universe continues to expand, galaxies will drift farther apart. Stars will burn out, one by one, leaving planets cold and dark. Eventually, the cosmos could become a vast, frozen emptiness, where energy is spread so thin that life, as we know it, may no longer exist. Time would continue, but the universe would be quiet, a vast silent ocean of ice and shadow. Another possibility is the Big Rip. In this scenario, dark energy continues to accelerate the expansion of the universe until galaxies, stars, planets, and even atoms themselves are torn apart. The cosmos would literally be stretched to nothing, a final end where the fabric of reality is ripped asunder. It is a terrifying vision, yet it reminds us of the incredible forces that govern everything we see. Some scientists imagine the Big Crunch, the mirror opposite of the Big Bang. Gravity might one day overcome expansion, causing the universe to collapse inward. Galaxies would collide, stars would merge, and matter would be compressed back into a singular point, dense, hot, and infinite. And in that collapse, some theorists suggest, another Big Bang could occur, beginning the cycle anew. These possibilities, frozen emptiness, tearing apart, or collapse and rebirth, remind us that the universe is not static. It is dynamic, alive in its own cosmic way, evolving across time scales far beyond human comprehension. Yet within this immense flow, life has arisen, consciousness has emerged, and we have been given the privilege of witnessing it. As we imagine the distant future, it is impossible not to reflect on the present. Every moment we have, every thought we form, is a miracle in a universe that could have been empty and lifeless. The atoms in our bodies were forged in the hearts of ancient stars. The sunlight that warms our planet has traveled across space for millions of years. We are part of the universe, not separate from it, and in our awareness, we carry its story forward. Looking outward, we see galaxies colliding, stars exploding, and black holes bending time. Looking inward, we see minds capable of wonder, imagination, and love. The universe has made us, in a sense, to observe itself, to ponder its beauty, its mysteries, and its infinite complexity. In every star, every planet, every cosmic phenomenon, there is a reflection of our own curiosity and awe. Perhaps the most profound truth is this: the universe may be vast beyond comprehension, but consciousness allows us to connect with it, to understand it, and to dream. Our lives are fleeting, yet in those fleeting moments, we become part of something eternal. Every discovery, every exploration, every question we ask echoes across time and space, leaving a mark in the cosmic story. And so, as we gaze at the night sky, we are not just looking outward, we are looking into ourselves. We are participants in a grand adventure, co-authors of a narrative that began billions of years ago and will continue long after we are gone. The universe is both home and teacher, guide and mystery, challenge and inspiration. In the end, the cosmos is not simply a collection of stars and galaxies. It is a reminder that from nothing, everything can emerge, from chaos, order, from darkness, light. And in that endless unfolding, we find our place, small, fleeting, yet capable of wonder, imagination, and understanding. The universe is vast, mysterious, and eternal, and so are we, in our own way, part of its infinite journey. As this journey comes to a close, let us carry the stars with us, in our thoughts, our dreams, and our hearts. Let us remain curious, bold, and mindful of the fragility and beauty of life. The universe began from almost nothing, yet it created everything. And within it, we exist, aware, alive, and capable of marveling at the extraordinary story unfolding around us.